Students, I have some help for you this week for Chapter 10, reconstituting IV and IM medications from a powder form. And this is going to help you with this week's homework assignment as well as this week's exam. So I have the first problem here, which we're going to give some Augmentin to a patient, and it's actually to a kiddo because we have to get 10 milligrams per kilogram here. But in our question it has Augmentin 10 milligrams per kilogram PO every 8 hours is ordered. Augmentin is reconstituted per above drug label. The child's weight is 25 kilograms. And the first question says how much diluent is added. So we go through here, and typically when we have reconstitution instructions, they're going to be over in the smaller print. So over here it says directions for mixing. Tap the bottle until all powder flows freely. Add approximately 2/3 of the total water, which is 67 milliliters, is what we're going to add to this. And then it says shake vigorously to wet the powder, and then add the remaining water after that. And our total concentration here is going to be this, and usually it's in pretty big bold print. So our final concentration will equal 125 milligrams per 5 milliliters. And now we want to know how many milliliters will you give. So, of my information that's up here in my question, now that we've answered these two, it says Augmentin 10 milligrams per kilogram is ordered. We have the final concentration, which is what we have to use in order to figure out how much of this medication we're going to get. So that's going to be 125 milligrams in 5 milliliters. And the child's weight is 25 kilograms. And we want to solve for how many milliliters right here. So what I do first with these is I always get my kilograms out of the way. And how you can do this, again, it's the same kind of premise as figuring out, so we want to know milligrams in this case, because that's what we have here. So we have 10 milligrams per kilogram, and then our kilogram here, again, to cancel out, is 25. So ultimately we're going to just multiply 10 by 25, and that is going to give us 250 milligrams, because our kilograms cancel out, per dose. So this is what we're now solving for as far as getting the information for our milliliters. So we've used our kilograms, we've used our 10 milligrams per kilogram, so now we're left with 250 milligrams, and what we have on hand is 125 milligrams in 5 mils. And again, solving for milliliters, so go back to your dimensional analysis. I'm going to start out with milliliters here, and of the two information pieces that we have left, I have 5 mils, and there's 125 milligrams in there. So I'm going to write that, and per dimensional analysis again, since this is milligrams, this has to be milligrams, and now what we're left with is the 250 milligrams, and that's going to be over 1, or per dose. So now all we have to do is the math across. So 250 times 5, that gives us 1250, and then we divide that by 125. Milligrams are going to cancel out, so we're going to get something left in milliliters here. So 1250 divided by 125 gives us 10 milliliters. So that's how much we are going to give to this particular child who weighs 25 kilograms, and the doctor has ordered 10 milligrams per kilogram per dose.